Okay, where did we stop? Last class.
Refraction.
We started or?
Yeah, so we
So where we start?
and then we went back and
We started.
Did we cover refraction by rectangular glass slab? नहीं किया.
Just start.
Just start करके define किया था क्या होता? अजी क्या बोल रहे हैं? Snell's law तक हो गया. Different relations between refractive index. इसने नोट किया नोटबुक दिखाओ.
We have written laws of refraction.
पूरा लिखा तुमने? So last class में what we did was laws of refraction. So basically two parts. One is incident ray is equal to incident ray, refracted ray, and normal. Yeah, I know. And they are in the same line, right? Same plane, same plane. ये हमने कर लिया. दूसरा क्या किया था? Snell's law. Sin I by sin R is equal to n to 1, or it is written as n to 1. Correct? I have given you both these notations.
Yes.
It is also sometimes written as mu to 1 or mu to 1. How do we read this? We don't read it like this.
We first read it.
We first read it 2. And we don't read it as mu. We say refractive index of second medium with respect to first medium. What is second medium? Second medium is the refracting medium, where the path of light changes, okay? And the first medium is incident medium. So where the direction is changing in the second medium. So refractive index of the second medium, the bending medium, with respect to first medium, because it is always the pair of medium. Now this law is applicable for a pair of medium and a given color of light. It is applicable for a pair of medium. Did we write this?
yes, sir.
This law is applicable for a pair of medium and a given color of light. Now what is the meaning of a given color or given wavelength of light? Single color. Okay? Which means if it is a white light, it has got 7 colors in it, and each light will bend differently. The property is different. Okay, so all those things. So you have to mention that this law is applicable only for a monochromatic light ray. Okay. All right. Now we'll see some relations. There is one more definition for refractive index.
N by 2 divided by N by 1.
Refractive index is also defined as
N by 2 divided.
V1 by V2. We are coming to N by 2. उसका derivation अलग से है. What is V1 and V2? Where You should guess it from 1 to 1 is the first medium, incident medium, 2 is the refracting medium. So V1 is speed of light in the incident medium or the first medium, and V2 is the speed of light in the second medium. V1 is speed of light in first medium. V2 is speed of light in second medium. Okay, so therefore refractive index is also defined as ratio of speeds of light in different mediums. Right. So what is the physical significance of refractive index? Physical significance of right. So like V1 is equal to N21 times V2. So refractive index is the factor by which the speed of light will increase in vacuum over its speed in the medium. Okay? Or it is also the factor by which it will decrease in the medium, if you write it like this. Okay? N21 or the refractive index of second medium with respect to first medium is actually a number. Okay? For example, so for water, refractive index of water is water with respect to air. It is also written like this alphabetically. Refractive index of water with respect to air is 1.33. Okay. So, what does this mean? What does this mean?
The speed of light in water with respect to air.
Yes. Speed of
Speed of light in water with respect to air.
is how much? It is 1 by 1.33 times of speed of light in air. It's like that. So, this is the factor. So, here, what is speed of water? Speed of light in water is 1 divided by 1.33 into 3 into 10 raised to 8 meter per second. Any idea how much is it 4 by 3? How much is 4 by 3? Yes. Okay. So with this, you can write it as 3 by 4 into 3 into 10 raised to 6 into 100 euros. 25. कितना आ गया ये? 25 2.25 into 10 raised to 6 meter per second. So speed of light in water is this. Got it? So the refractive index of a medium gives you the idea about what the speed of light is going to be in that medium. Okay? So that's the physical significance of refractive index. Okay. It's given. It gives the factor by which the speed of light changes in the refracting medium. Okay. So if any medium has a high refractive index, like this is water का refractive index. Higher the refractive index of the medium, slower the speed of light in that medium. Okay. So there is a table given in your book. Table listing the refractive indices of many mediums. Right on page 56. So you can see the highest refractive index is of diamond, 2.42. So speed of light in diamond is going to be the lowest. And obviously it will be highest in air because the least refractive index is that of air. Okay. All right. Okay, so this is the alternate definition of refractive index. Next is concept of absolute refractive index. Let's see what is absolute refractive index. I am writing short form for refractive indexes Ri. So now we have seen this definition, right? So when the first medium is air it could have been glass and water, right? So V1, V2. If the first medium is air, then the speed is C. If the incident medium is air. Then C1. In this case, we drop the first medium. It is written as N2. Okay? And N2 is called, so N2 is called absolute refractive index of the second medium. Or just the medium. Because N2 is now the refracting medium. Okay? So when we say absolute refractive index of the medium, it means the refractive index of the medium. So we understand that first medium is air only. And all the table that you are seeing, these values are with respect to air only. Okay? So all these values are refractive index of listed medium written on the left. So these are all absolute refractive indexes. Got it? Now you have to understand whenever the refractive index of the substance is given, and if the incident medium is not mentioned, then it has to be with respect to air. And it is absolute refractive index only. Is that clear? So now, okay. Or it is just written as N. Even 2 is dropped. So you have to understand that it is the second medium only. Is that clear? Yeah. Just the medium. When it is just the medium, then even 2 is not written. That is okay. Some more relations involving so these formulas will be helpful while tackling numericals. So since N21 is equal to what is it? V1 by V2 in general. Correct? So now you can divide by speed of light, divide and multiply and divide by C. Can we do this? Multiply and divide by C. Now we will group C by V2 divided by C by V1. Can we do this? Can we do this? We can take A by B divided by C by D, right, is equal to A into D divided by B into C, correct? So that formula. So what is this now? What is C by V2?
Absolutely.
N2. What is C by V1?
And
N1. So N21 can be written as N2 by N1. N21 is equal to N2 by N1. This is the expression of refractive index. Okay, this is called relative refractive index, and this is called absolute refractive index. So this is the relation between relative refractive index of two mediums with respect to their absolute refractive index. So example, if it is not air, it could be NGW. So what it is now? It will be Ng upon NW. Correct? If it is glass and water, relative refractive index of glass with respect to water is nothing but ratio of absolute refractive index of glass to absolute refractive index of water, or just the refractive index of glass versus refractive index of water. Okay? If you don't mention absolute, just the medium, then also it is absolute. Clear? You are not mentioning the second medium. Absolute. Okay, just him. So we have written so many useful relations. Also, you just give it a number. One. Then you have since N21 is equal to sine of I upon sine of R. This can be written as 1 upon sine of R divided by sine of I. Right? So can we write this as 1 upon N12? Okay? For example, you see right, so let's say this is medium 1 and this is medium 2. So in this case, when the light is incident in the first medium and when it is bending towards normal, this is denser medium. So this is valid for the first case. Correct? Now, if I flip this, same thing I flip it, then what will be my incident medium? Second medium. What is my refracting medium? First medium. Okay? So I am just reversing the path of light for the same pair of medium. Then what do I get? I will get sin R by sin I. So what is sin R by sin I? Refractive index of
first medium and
refractive index of first medium with respect to second medium. Now, my first becomes second and second becomes first. You get it? See, if I change the direction, let us say my light is now going like this. Okay, I put some reflector, and it was incident along the normal. Then the light will be sent back. So there is a law of optical reversibility of light. Optical reversibility of light. It says when the path of light is reversed, it will retrace the old path. Whichever path it took to come, it will go back by the same path. So then angle of incidence becomes R. What is medium of incidence? 2. What is medium of refraction? 1. Then it is 1. Okay, so this relation also works. So this relation, right? And it is applied to various mediums and the Snell's law. So there are so many combinations possible, and for solving numericals, you have to use one of these. Okay? And also this. So 4 relations we have learned. Apart from this, the Snell's law. Okay? 4. So we have covered all the relations related to refractive index. Now we'll cover refraction through a glass slab. Okay, so you may complete the notes till here. Then I'll explain here. This is our fourth class, or which lecture is this? Fourth or first, you right? No? Then who will tell you? You are. So those who are present in all the lecture. Fourth lecture? Okay. Fifth it is? Fourth. Are you writing the dates? Which one? It's not the fourth one. Count the Mondays. I think we started on 24th. So how many Mondays? Okay, 24th March.
Fourth class.
Fourth year. Because if it is fifth, then we are running, we are falling behind schedule as well. In school, this chapter is completed for some of you? Not yet. Start किया है? Start कहाँ पे किया है? I think your school it is started, right? Till refractive index. जितना हमने अभी किया है. Lenses का ray diagram हो गया? Not yet. Till refractive. हाँ? Of mirrors or lenses? Okay, now okay, now let us discuss. Can I discuss now? How many of you are still writing?
So, in my exam, the chapter is
You know, oh, that's still. You can ask down. Hold up. Crystal, hold up. So what's potential difference? Ohm's law. So Ohm's law is very simple actually. See, if you have we are digressing for 5 minutes. Okay, excuse. So in the meantime, you can let's say you have a simple electrical circuit, right? Right. This is a conductor, right? And conductor has a resistance. That resistance I am representing by R. Ohm's law simply says that when we apply potential difference across the conductor, right? Then it is always produced to the it is always proportional to the current producing. This is Ohm's law, right? So it only gives the relation between the applied potential difference and the current produced. So if the other parameters of the conductor don't change, such as its physical dimension or its temperature, right? So at constant temperature, this is obeyed. Okay? And so therefore, when you remove the proportionality, you have to say constant. This constant is for a given material. Okay? It is constant. And that is called resistance of the material. Right? So resistance therefore, so this is called Ohm's law. Yes, this is the answer.
So if the definition as a structure.
We'll write for a write down for a given conductor. It's given in the book. Textbook. Okay, anyway, you take it. For a given conductor, the potential difference applied across the conductor is directly proportional to the current flowing through it. Provided its temperature remains constant. This is what it is. Provided its temperature remains constant, and then mathematically you just establish this relation. So where R, that constant is called resistance. That's it. And then you can just write down therefore R is equal to V by I. And the unit of R is ohm. Okay, and also if it is for Ohm's law, you have to also draw the VI curve. And V is directly proportional to I. So the graph has to be straight line passing through origin. And the slope of VI is resistance. Graphically, how you calculate the resistance? So you take any wire in the experiment, you make the observation table. So what you will do? Here you will put a voltmeter, and here you will connect current. Okay, ammeter. And here you will have some kind of rheostat. So you will start with 0. Then where is the rheostat? You will see, go in the graduations of 1 volt, 2 volt increase and record this also. So you will be able to create an observation table. Again, this is serial number 1, 2, 3, 4. So you will see various values over here, and you write the corresponding values here of voltage and current. So this is by experimentation. Then you do V by I calculation for each observation, and you will see that this is constant. Same value for all. Yes. So this is resistance. So this proves Ohm's law. So this is experimental verification. Entire chapter is coming for electricity.
Yes.
You should have other doubts also. Potential difference yet to be done. Come up with questions in the next class. Yeah. Especially the series parallel combination and all those. So that is where we get doubts.
That's just experiment.
Okay. But you should have doubt in what is potential difference.
Voltage.
What is it? Voltage is unit of potential difference. So, potential difference is the property of the electric cell, right?
I actually had a potential difference W in potential difference. I doubt I asked mom. Then she explained it. I couldn't understand. I was
Exactly. So I will explain you in the next class. First you read, okay? There is a difference between potential and potential difference. Without this, you cannot understand anything in this chapter. And this is the starting of it. So potential, electric potential is different. Okay? Actually same, little bit minor difference, but this is practically more useful.
It's the pressure which is applied to the electrons.
They say, so like water flows, if you have a pipe, okay, at the same level, and there is no difference in pressure at the ends of the pipe, will the water flow? So that is a mechanical pressure difference needed for the flow of water. Just like that, for the flow of current, you require electric pressure. Okay, that they are calling. This is how they have explained in the book. So that difference. So here there is a different potential. The potential here should be high. So positive side has a high potential. Negative side has a low potential. Then if you connect any conductor between the high potential and low potential, okay, then the current will flow. So this is at high potential plus, this is at low. And how this high and low is created? Through chemical reaction. So I'll have to explain that in detail. It's a big discussion.
I asked her that what kind of chemical reaction so they
I know even people do 12 and engineering also. Even then this funda is not clear. Okay, so the whole thing is because this is the source of energy. Without this, the current won't flow. It's a fundamental question. Everybody, I mean, they may know, but articulating it is a challenge. Okay? So I'll explain it. Okay. So we are good about refractive indices. Okay. क्या मिटा दिया मैंने? अच्छा टॉपिक.
refraction of light through a glass.
हाँ. If you have only covered Ohm's law, then it's only the 30%. More than half is remaining. The series parallel resistance and also the power calculation and the heat produced. So a lot of things are pending. Okay. You have a rectangular glass slab. Let's say this is the rectangular glass slab, right? So it will be like a cuboid shape and it will be totally transparent. Okay. So you will be required to do an experiment in your lab, right? So let's say this is the table on which you'll put a chart paper and then keep the glass slab like this. Okay. Then what you have to do is you have to insert two pins on the other side. Okay. Let's say a pin here and a pin here, right? And then watch those pins from the other side. This side and this side, okay? Pins are here and you're observing those pins from the other side. And you have to see in such a way, right? So such that only this pin, the pin towards you is visible, right? You can see like this. When I see with one eye closed, if I see only this pen, the behind pen is not visible. That means they are in the straight line, correct? So the idea is while doing the experiment, when you're observing from the other side, only the pin towards you should be visible, right? So with that, now what you have to do, imagine only the pin towards you is visible. With your one eye closed, you now insert another pin this side. And this is also in the same line, so you're only able to see this pin. Then insert one more, so that only this pin is visible. So which means, as per you, all the pins are in the same line, correct? Only when the objects are in the same line, you will see only the front object, Correct? So basically, and then, so at the start of experiment, you place the rectangular glass slab here and run the pencil. So you have the position of the glass slab. Then you insert two pins. That positions also you have. You just when you remove the pin, there will be impression. Just mark it. Okay. So and you have also inserted the pins here while doing the experiment. Okay. Now what you do? You just we need just 2 points to draw a straight line, right? To draw the straight line. Actually. Then what we have seen is the straight line is over here. When you join the dots, you find the straight line over here towards you. And then when you join these two, actually you get this. While conducting experiment, all the pins were appearing to you in the straight line. But when you remove the pins and join the lines, so between the glass you see a deviation. Expected. This is expected because now when you draw the normal, right? So where is the original direction? Okay. And these rays are parallel actually. It is not come out very well. That's how we try it. This is 1, 2, 3 and 4. Okay, this is what you get. Okay. So while seeing, you see all of them in straight line, but actually this is what happens. So this is your I1, this is R1, this is I2, and this is R2. So what is observed is there a deviation between the incident ray and refracted ray?
Yes.
Deviation. Is there any angle? What is the angle between two parallel rays? So if this is the line, there is some inclination, there is angle. If they are parallel, is there any angle? Zero, right? So there is no deviation. We say here it is deviation, right? This is deviation. If there were, this is deviation. See, this is the original direction, and this is the different direction. But here, this is the direction. This is also, so both directions are same only. There is no angle, correct? So what do we observe experimentally is, in a refraction of light through a rectangular glass slab. You have to mention rectangular. Because opposite sides of rectangles are parallel, right? So only in that case, the emergent ray, this is called emergent ray. This is incident ray. Right? And this is refracted ray. This is refracted. Even this is refracted because medium change, right? So refraction taking place at two plane surfaces of glass slab. So since the pair of mediums are same here, the amount of deviation caused at the first surface AB, that deviation is negated on the second surface. Okay? So that's why the emergent ray is parallel to the incident ray. Right? What is the first observation? So there is no deviation, just lateral shift. So you can call it XY. In refraction of light through a rectangular glass slab, there is no deviation. deviation in the emergent ray. Second, the emergent ray is laterally shifted. Okay, so sometimes there may be a question asked, draw the ray diagram to show the refraction of light through a rectangular glass slab, right? So first you draw the ray diagram and then list the observations. These two things you will see. Okay, there is no deviation. For deviation, there should be angle between this and the final ray. There is no angle, they are parallel. But it is laterally shifted, parallelly. So this is a lateral shift. Okay, lateral shift. Is that clear? That's it. So here, angle of incidence is equal to angle of emergence. Third thing you can write is, has to be that angle of incidence angle phi ठीक है angle of incidence is equal to angle of emergence. There is Ohm's law given in your book also, like in this diagram. Okay, so the electric current flowing. This is also possible. You can write it photos. So this next to the graph. Everybody understood how to draw the ray diagram for refraction of light through a glass slab, right? So with this, now we can discuss the spherical lenses, refraction through spherical lenses. So let us define what are the lenses. Just like spherical mirrors, we have two different types of spherical lenses. What are they? Exactly. Here, everybody is volume. There is one more thing, even for a given angle of incidence and a pair of media, the lateral displacement is proportional to the thickness of the medium. Okay, see this. If I replace this glass slab with a more thicker, like AD increases. Now, if AD increases, you can see that this shift also will increase. Correct? If AD increases, this line will be bigger, then it will go from here. Correct? So what will increase? XY. What is the lateral shift? XY. So sometimes there may be a question. So it is given here in the italized form. Okay. So just take note of that as well. Now, what are the applications of refraction of light? So these are the natural phenomena that you will observe. Just go through it. What are they? A pencil placed partly immersed in a beaker of water appears broken at the interface. Did anyone try? In the last class, I had told you, like if you in the bucket, did you try that and see?
In the glass.
There also you will see. Just the check up. Then second is a coin placed at the bottom of a bucket filled with water appears elevated. Just like we discussed, when somebody enters in the swimming pool, the legs appear shorter. Okay? Or the portion of body inside the water will appear shorter. Okay? An object placed in denser medium when viewed from the rarer medium appears same thing. Like pool, you see that it is appearing shorter, and when you see it like this, something kept in the glass, it appears nearer. Same thing. So why it becomes this? Like it is raised above. That's why it appears shorter. Okay? So the depth looks shallow only because it is come near to. Object placed in the rarer medium when viewed from the denser medium appears farther. Ulta ho jata hai. It appears farther. We can actually see all of these by drawing the ray diagrams. Okay? So I'll try and do it in one of the situations when we'll discuss. Apparent altitude of stars is more than the actual altitude. Why so? Where are stars?
Stars
In the rarer medium. So space is rarer medium. And how do we see stars through? We are seeing through atmosphere. Atmosphere is a denser medium. So we as an observer, we are in the denser medium and we are seeing the object in the rarer medium. So it will appear far away. Correct? So apparent altitude of star is more. So star appears actually more far away than actually it is. Right? We will discuss this with the help of ray diagram. Apparent length of the day is more than actual length. Apparent length of the day is more than actual length. So when sun is rising, okay, before actually it has risen, right? If this is the horizon of Earth, so the sunrise, you actually see the sun. It's not actual sun. It is still below the horizon. But it appears at least 2 minutes before due to refraction of light. Because sun is in space, right? And then it is entering Earth atmosphere. So sun ka light ऐसे आके bend होता है towards us. And we feel that sun is above. It's actually not above. Okay? So that's what it means. So let's go ahead and discuss refraction through lenses. Anybody has any question so far? Everybody looking at each other? Nobody has a question? Okay, so what is a lens? What is a lens? It is a bound transparent medium such that there was only one black marker. It is a bound transparent medium such that one of its surfaces is spherical. Okay, it's a bound medium. So therefore, we have two lenses possible. Right? These are the two lenses possible. You can have these kind of lens also. So here only one surface is spherical, the other is straight. Okay, there are other curvatures possible like moon shape. Okay, so at least one surface should be spherical. That's the idea. So the name for this is doubly convex. I don't know, just check the spelling, doubly convex. Is it correct? Doubly convex or just convex or just convex. So when you just mention convex, so both its surface bulge out. Okay? So it is thinner at the edge and wider at the center. Okay? And in this case, it is wider at the edges and thinner at the center. And this is called doubly concave lens. Double की spelling नहीं आ रही है, double की.
This is double.
Double.
Only double.
Like this.
Yeah.
No, it's doubly, right? Or double.
But in the book it's written double.
Double only. ठीक है चलो. Double concave lens or just concave. ठीक है. So this is how you will identify them. This is called plano-convex and this is plano-concave. Okay? Plano-concave. This is plano-convex. So the final word is the deciding factor. So it is a convex lens. But which type? Plano-convex. This is a concave lens. Okay, so it is thinner in the middle and this is thinner at the edges. Okay. Right? So I think we'll now go through formation of images by convex lens first, and you will find that the nature and position of image is same like that of concave mirror. Okay, only thing is the front image will now appear behind in case of convex lens with the same nature, whereas all the real images will form behind the lens and the virtual image will form in front of the lens. Yes, that's it. That's the only difference. Otherwise, everything will be same. Okay, just front and behind, that will change. So it is going to be very easy. The hard part of this chapter is already done. The hard part is still the concept of refractive index. The rest is just a easy one. Okay? So maybe in the next couple of classes we'll be able to complete the chapter and then we'll do assignments. Right? Is it time? Okay, I'll see you in the next class.
So usually right now, I was happy to see you. I was happy to see it. Because it is my circle. Like so. And then we say we started. But इतना बंद किए इसलिए
कोई आया भी नहीं, यूजुअली आ जाते 4-5 लोग तक
है ना